This video is a presentation from a webinar hosted by satsearch on thruster technologies for small satellite missions. It's led by Federico Torridi from Exotrail, an in-space propulsion manufacturer that develops solutions for an agile space. Exotrail is a participant in the satsearch membership program and offers a portfolio of Hall effect thrusters at various scales, as you can find out in the video. Enjoy.
Yeah, no, I think that it's great to be here and have the possibility to discuss about this topic that is kind of critical right now, because for sure propulsion is nothing new for satellites in general. What is new is that it's increasingly becoming a must for all the satellites, even the smallest one. And as Lou, in my opinion, correctly pointed out before, we are in the situation where there are several satellite manufacturer operators that could not have all the expertise they need to deal with propulsion. And I mean, propulsion could require quite specific expertise in areas ranging from the mission design to the integration to the operation itself. So thanks for this opportunity, and let's start. So just a couple of words. Exotrail is a French company. There are close to 40 people right now at Exotrail. The objective is to be 60 end of the year. We are split between Toulouse and Massy, where the headquarters are located together with the team developing the propulsion systems. We have raised so far close to 18 million euros. With the last fundraising happening last July. What is our vision? Our vision is really to holistically improve the space agility, so to provide mobility solutions for the small satellite markets in particular. And we are trying to do so, we want to do so by relying on three main pillars. The first one being the improvement of deployment solutions. So to give small satellites a higher number and higher quality deployment strategy solutions, as well as improving their possibility to increase the performance once they are in orbit, either by optimizing the way they do operations, in particular for constellation, as well as increasing the performance of the payloads and hence the revenues for the operators. Last but not least, of course, also the mitigation of space pollution, either by giving satellites the possibility to perform collision avoidance and to the orbit, and as well as in the future to provide services to do orbit removal. We have two main line of products right now, which we think are very complementary to achieve that. The XMG propulsion system family, the main topic of today, and then XOPS, which is our mission design optimization operation software, which is essentially really one-stop shop, providing the operator, the manufacturer, with all the means it needs to first design the constellation, to understand which is the best propulsion solution to be implemented on the spacecraft, to define the mission plan, and eventually, of course, also to do the operation itself. We have a last development, which will become a product in 2024, which is the Space Van. So it's essentially an electric propelled space tag, so meant to embark smallsat, and after the deployment from the launch vehicle to move them in the orbit they want and then release them, of course. So our XMG family is I say family because it's not really a single product, but as an ensemble of Hall effect thruster propulsion systems. So nothing new. Hall effect thruster technology is a quite old technology that first flight in the 70s with the Russian thrusters, and it's I would say always based on 4 blocks, which in our case are really building blocks because of our modular approach, meaning that all the configuration that we made are always based on the same electronics and fluidics. The fluidics being the module distributing the propellant from the tank to the thruster head, which is the module actually generating the thrust, and the electronics managing the power coming from the satellite and treating it in order to feed the thruster head. So we have, let's say, 2 variables to make our configuration. The first one is the tank. Depending on the delta V needs of your mission, we can choose the proper size of tank. We have a family of pre-qualified tanks. And the second variable is the thrust level, which can depend on the size of your spacecraft and your mission needs. We have to tackle this, we have two thrust threads, one 60 watts class thrust thread and one 150 watt cluster thread. And then we do clusterization with the micro, so up to 4 micros. In this way, as you can see here, we have a pretty wide range of performance we can offer. In terms of thrust, we can go from 2.5 millinewton with the nano up to 30-35 with a cluster of 4. In terms of total impulse, we range from 1 kilonewton second up to 250. In this way, we can meet the needs of platforms ranging from like 10 kilos, so 6 CubeSats, up to 250 kilos. A couple of words also about what we have done and reached so far. We successfully performed our IOD mission with a nanoavionics platforms and last year, where we nominally performed a characterization of the system, maneuvers, ignitions, and also characterization of the performance that was actually higher than expected. It was good, honestly. And hopefully in 9 days, we should be again in space with an aerospace platform on the Falcon 9 Transporter 2 mission. This is a pathfinder of an upcoming Earth observation constellation from Aerospace Lab, and we are also about to deliver 2 other systems to Clyde Space, and those one will be embarked on the HALO 3 and 4, which are the pathfinders of the Eutelsat Internet of Things constellation, HALO. Then we have also other projects ongoing with institutional customers, several, ranging from the ESA, CNES, the European Commission, the French government, as well as also with other commercial customers. So now diving into the central topic of today. First of all, I will need to be a bit quick, but no worries. I mean, we'll share the material afterwards, and you will have all the time to see all the details of the different slides. So was really to give an overview, which is the typical, time frame and time scale of a project with us. I say a project because we would like really to have this approach that support the customer from the really beginning to the very end. This is also complemented by XOPS mission design, indeed. So the definition at the beginning of which are the requirements of the propulsion system, depending on the needs, and to the end, to the operations. So coming back to this point, if you have a company and that company doesn't have the expertise, all the expertises it needs to implement propulsion, the idea was to have all the means we needed to give them the possibility at the end to enable the possibility of propulsion on board of their spacecrafts. So the standard package we want to offer is not just about the hardware. It's all it is needed from A to Z. And just if you need some specificities, depending on the project, we can add other options, increasing the flexibility of the package, meaning additional milestones, extended data package, higher quality, additional tests, whatever. With the same philosophy, here I wanted to show a bit some possible LEO use cases. I defined this through our software, XOPS. And the point is that propulsion is quite key within the overall constellation project. I'm saying so because properly defining the proper propulsion technology and performance could have a huge impact in the overall business case. I can take 2 examples. For example, let's say that you don't have a propulsion system capable of performing post-launch maneuvering. This will force you to rely on rideshare launch. and so you will not sure to be in the proper operational orbit slot you want to be. You need to go to a dedicated, and in this case, the cost you need to pay for the launch will be higher. So this is a parameter you should take into account really at the beginning of your the definition of your project. Second example, for example, it's the time to orbit. Let's assume that your propulsion system has not the proper level of thrust. This could translate in, let's say, 1 year of time to get to the operational orbit after the deployment. If your small sat have just 5 years of lifetimes, this means that you have reduced of 20% your total revenues and delayed your revenues of 1 year. So this is why it's quite important to accurately account for all these elements since the beginning, and this is also why we want to offer not just hardware, but also all the software you need to perform these trade-offs, which I mean, was expertise to do that is not easy to get there, either in terms of time and money. So this is why they think that as a propulsion provider, we need to give these tools and not to have these tools already within the company, the customer. This is a bit, I showed before some use cases ranging from low maneuver capabilities to very high maneuver capabilities. Then the second parameter you need to account is the size of the platform. And depending on these two variables, we can define which is the proper XOMG configuration could fit your use case. And this is an overall map of what we can offer and how we can meet the different needs in this sense. The second degree of flexibility we offer with XOMG is that through our modularity, we are not forced into one single form factor. So once we have defined the performance you want for your mission, we can then define a form factor that fits seamlessly in your platform volume constraints. Another step we wanted to took at the really beginning was to simplify to the maximum extent the interface, as also Lou pointed out before, in terms of mechanical interface, electrical interface, thermal interface. Quite often with propulsion you have problems deriving from dissipation, so this is the reason why we put quite a lot of effort in the decoupling to the maximum extent, the thrust thread, not to have too much dissipation towards the spacecraft, to offer several options in terms of a communication protocol, in electrical interface, as well as I mentioned before, the flexibility to have different form factors. Another important point, we decided to follow this envelope approach, so using a qualification envelope covering the majority of the launch vehicles available in the market, so to be compatible with as most as possible platforms and launchers. Then this is, for example, the standard offering we have. Then, of course, you have the possibility to customize it. This is a pretty standard functional vibration, TIVAC, and functional test. Then, depending on your needs, we can introduce additional tests. For example, on the right, you can see the full coupling test we perform with an avionics platform, which was something we wanted to do with our first customer to mitigate any risk coming from EMC or other possible, any other possible interactions between the propulsion system and the satellites. Usually around the community, there are some concerns about the utilization of liquid propellants and pressurized systems. That this can be true, but just if you have not done your homework in advance. So what we have done is to perform all the analysis we needed to be sure that at the end the customer will have absolutely no troubles in terms of launch safety and transportation with our systems. So our baseline is to deliver the propulsion system already filled. Then if you need it, we can offer several options, both to sell you directly in the xenon filling machine we have designed, either to provide you with directly the xenon filling service. And in terms of run safety, we work to be sure that we are compliant with all the launch pads available around the world, from Europe to US to India to Asia. So to not have any hurdles coming from these 2 points. In terms of integration in the platform, together with our standard offer, as I showed before, we offer also support during integration. The system is made to be very, very easy to be integrated on the platform, so you just need the standard ISO 8 clean room. We offer with the system also a very easy plugin software to check the health status of the system after integration. So I would say that you do not require any specific expertise in-house to integrate the system. In terms of space operations, we have several projects ongoing to provide thrust vectoring by 2023. No problem to operate the propulsion system while payload operation. Of course, as a disclaimer, you need to be in the proper attitude to operate simultaneously both the payload and the thruster, and you need to have you need to have accounted for the proper energy balance overall. And I would say that is everything. So thank you a lot for the attention, and I will available to answer any question you may have.
So there we are. I hope you enjoyed this short video about small satellite thruster technologies and how they're used in space missions today. To find out more about Exotrail, please go to satsearch.com and search the platform for information on their products and services. Also, do let us know if you have any questions or comments, and thanks again for watching.